Hi, my name is Lydia. I am a science ambassador here at the University of Texas at Arlington. Today, I'm going to show you guys a demonstration on acids and bases. Acids and bases are solutions that range on a pH scale. A pH scale ranges from 0 to 14, with 7 being neutral. 0 to 7 is going to be a solution that's more acidic, whereas 7 to 14 is going to be a solution that's more basic. Some common acids that you guys might consume are fruits such as pomegranates, oranges, strawberries, whereas some bases, we don't normally consume too many of them. So bases, on the other hand, are often used for cleaning, which include ammonia, bleach, and even toothpaste. So now we have an idea of acids and bases, I'm going to show you guys these 3 flasks here. These flasks contain 3 things: water, sodium hydroxide, which is a very strong base, and phenolphthalein, which is a indicator. These 3 have a basic solution shown by the bright pink color of the phenolphthalein that comes in contact with the sodium hydroxide. So I want you guys to think about what I might do to turn a base into an acid. And if you guess using an acid, you are correct. So now that I want to turn these basic solutions into acids, I have 3 different acids on the table. We're going to start on this side. This side has our most acidic acid on the table, which is lime juice. The lime juice pH ranges from 2.0 to 2.8. So what I'm going to do is just add that to our basic solution here and see what happens. As you can see, the color that the phenolphthalein had turned completely clear, which is an indication that we now have an acid. All right, let's see if the other 2 acids are as acidic to also turn these into acids. So the second one here I have is acetic acid, or more commonly known as vinegar. Have you ever done those volcanoes where you can pour in the vinegar and it makes, an explosion with the baking soda? That's the same vinegar that I'm using here. So vinegar has a pH of about 2.4, and I'm just going to add that to our basic solution. And as you can see, it is also completely clear. So far you've had 2.0 to 2.8, this one's 2.4. These have turned our basic solutions to acids. All right, our last acid on this table is soda, and it has a pH of around 3.2. So this one's definitely less acidic than these 2, so let's see if it's strong enough to turn this base into an acid. The answer is yes, it is. So I'm now going to show you guys how to turn a base into an acid with the use of a neutral substance. So what I have here is something you guys might have seen around Halloween. It is dry ice. Dry ice is called dry ice because there's no water inside. That's why you don't see anything dripping. And that's also why you see these vapors coming down. That's because of a process called sublimation, which is the process of a solid going and turning straight into a gas while skipping the liquid phase. So that's why nothing's dripping, it's considered dry. Dry ice is made of carbon dioxide, which is a gas that we exhale. And this is not like the regular ice that you guys have in your fridge. So dry ice is extremely cold at negative 109 degrees Fahrenheit. It's so cold that if it were to touch my skin, which is why I use tongs, it would feel like it was burning. Even though it's not actually burning, it's causing frostbite. To show you guys that it's not going to make like a little puddle or anything, I'm just going to put that dry ice there for you guys. So let's see what happens when we add this neutral compound to our basic solution. It may look like smoke, but it's actually vapors. Is the carbon dioxide is mixing with the water and turning it into carbonic acid, which is a common acid that you have in soda. So whenever you're drinking soda, you can think about how dry ice and water make carbonic acid. And thank you so much for watching, and we will see you next time. Please like and subscribe and share with your friends.